Hello students, so now we are going to start with Model Question Paper 1 2025-26 Part B Chemistry. Part A Physics already we have completed and the video is uploaded. So Part B also consists of multiple choice question and theoretical question. So question number 6 to question number 10 we are going to solve it in this class. So we will start with multiple choice questions. So question number 6, multiple choice questions. Here we have to solve 3 questions. Each question carries 1 mark. So total marks we are going to get from this question is 3. So question number 13, the constituent metals in brass are option copper and zinc, aluminium and tin, copper and tin, zinc and aluminium. So what is the answer? Answer, brass is an alloy. What is alloy? Alloy, it is a mixture of 2 or more pure metals or non-metal. And here the brass is mixture of brass, sorry. So the answer is brass is an alloy, and alloy is a mixture of 2 or more pure metals or non-metals. Here brass is a mixture of copper and zinc. So option number A is our correct answer. We will write the answer. Answer. Option A, that is copper and zinc. Now we will move with the next question. Question number 14. Analyze the experiment expressed in the above figure. The molecular formula of the solution Y that gives yellow color precipitate by the reacting with Ki solution and the another product that forms here respectively are. So this is the diagram which is given. So in this diagram we can see this test tube which is having Y solution, and this Y solution we are going to pour in Ki solution. We will get two product. In that two product, one product is yellow color precipitate and another product which is going to form, that we have to find out. So the question is, first we have to tell what is Y solution, and second is another product which is formed, that also we have to tell. So options are PbNO3 and KNO3, PbI2 and KNO3, PbNO3 twice and Ki, PbNO3 twice and K2SO4. So here this is lead nitrate and potassium nitrate, lead iodide and potassium nitrate, lead nitrate and potassium iodide, lead nitrate and potassium sulfate. So the answer is, when lead nitrate and potassium iodide are mixed, double displacement reaction occurs, forming a bright yellow precipitate of lead iodide and an aqueous solution of potassium nitrate. Therefore, the balanced chemical equation is, so what we are going to do? So the Y solution is lead nitrate. We are going to pour it in a Ki solution. This both undergoes double displacement reaction and we will get one yellow color precipitate, that is lead iodide, and another solution which you are going to get here, that is called as potassium nitrate. So our correct answers are, one is lead nitrate and second is potassium nitrate. So we will write the answers. So write down answer. Option A, and here the options are PbNO3 twice, that is lead nitrate, and one more is KNO3, that is potassium nitrate. So this is the answer. We'll move with the next question. Question number 15. A property of carbon that is responsible for giving rise large molecule is option tetravalency, catenation, inflammability and allotropism. So the answer is, what is catenation? That we will write it first here. Catenation is the ability of an atom to form covalent bonds with atoms of the same elements to create long chains, branches or rings. This property is most prominent in carbon. So here the correct answer is catenation, that is option B. So what the property says here, the atoms have the ability to form covalent bonds with the atoms of the same element, and due to this it forms many number of compounds. Some will be long chains, some will be branched, some will be rings, and there will be large number of molecules which are formed. This property most prominently we can see in carbon, and therefore option B is the correct answer. Write down the answer. So answer option B, and it is catenation. So this is the answer. We'll move with the next question. Question number 7. Answer the following questions. Here we have to solve 3 questions. Each carries 1 mark. So total marks from this section we are going to get, it is 3. Question number 16. How do you detect a base using blue litmus paper? Means the question meaning is, how you are going to detect it's a base by using blue litmus paper. So the answer is, when we dip red litmus paper in base, it will turn blue, showing it is a base. And when we dip blue litmus paper in the base, it remains blue. It will not change its color. Actually, what is litmus paper? Litmus paper are the papers which are used to check it's acid or a base. We have 2 type of litmus paper. One is red and one is blue litmus paper. So red litmus paper, if you dip in base, it will change its color to blue. Once it changes its color to blue, we should understand that the solution is base. And if you dip blue litmus paper only in the base, then it will remain blue itself. It will not change its color. And like this we can understand or we can detect the solution which is base or the acid. So the answer is, red changes color to blue and blue will remain as it is. It will not change its color. So the next question, question number 17. What are the applications of the thermite reaction? So here we have to write the applications of thermite reaction. Thermite reaction means the reaction in which high amount of heat is generated. Those reactions are called as thermite reaction. So the answer is, thermite reactions are also called aluminothermic processes used for thermite welding. So you can see here, wherever there is a welding in which we require high amount of temperature, those weldings are called thermite welding, and in such cases we are going to use these thermic reactions. Due to the extremely high temperature over 2500 degrees Celsius, so you can see here in this thermite reaction, the temperature which is produced, the heat which is generated, it is so high, it will be over 2500 degrees Celsius. And the production of molten metal, and in this process whatever pure metal is produced, it will be in the molten form. Because of this such a high temperature, the pure metal which has been formed, it will be melted, so it will be in the molten form. And due to this property, it is used for joining railway tracks and repairing large cracked machine parts. So the machine parts or the objects which you cannot carry anywhere, in such cases we can use this thermite reaction or aluminothermic process. So as you can see here, railway tracks, if it is having a crack, we cannot carry it somewhere into the machine shop and all. Even if we have large machines and if they have got a crack, we cannot carry those large machines to get repair. So wherever they are in that place only we have to get it repaired, and in those cases we can use this thermite reaction. So this is the answer for 17th question. We'll move with the next question. Question number 18. Write the structural formula of an unsaturated carbon compound containing 4 carbon atoms and ketone functional group. So see the question. We have to draw a structural formula for unsaturated carbon compound. It should have 4 carbon and also it should have a ketone functional group. The answer is actually 2-butenone. So this is the structural formula of this question, and this is called as condensed formula. This is called as condensed formula. So we will see how we got this structure. So first, as they have told, we have to take unsaturated carbon compound. Unsaturated means the compound which has double bond or triple bond are called unsaturated. Again, it should have 4 carbon atoms, 4 carbon, and then again it should have a ketone functional group. It should have ketone functional group. So these all categories, conditions we have to take it while writing this formula. So start writing. So first take 4 carbon. So I'll take 1, 2, 3 and 4. So as the condition they have mentioned, unsaturated means either it should have double bond or triple bond. I will take the double bond. So in this 2 carbon atom, I'll write the double bond, and remaining all should be single bond. Then what is the one more criteria? That is, you should have a ketone functional group. So any carbon, for any carbon you write down the ketone functional group. So what I have done, I have drawn here this ketone functional group. So you can see first condition is satisfied, second condition is satisfied, third condition is also satisfied. Now remaining all the bond should be written with the hydrogen atom. Carbon has tetravalency, carbon should have 4 bonds. So here we'll write H, this is one more H, this is one more H. So you can see 1, 2, 3, 4. 4 bonds are there for this carbon. Then for second carbon 1, 2, and already here 2 bonds are there which are of ketone functional group. So no need to write any hydrogen. For the next carbon we have 1 bond, here we have 2 bonds, 1 more bond is required, so we will write it H. And for the last carbon already 2 bonds are there, another 2 hydrogens we require. So this is H and this is H. So this is the structural formula for this unsaturated carbon compound. The same structural formula we can combine also. So how we can combine? We can combine the first carbon with this 3H. We can combine this carbon with this 3H, it will become CH3. This C double bond will remain as it is. This we can write it as CH, and this we will write it as CH2. If you write by combining these all, then it is called as condensed formula. Now the question number 8, that is answer the following question. Here again number of questions are 3, but each question carries 2 marks. Therefore total marks we are going to get from this section, it is 6. Question number 19. Draw the diagram of the arrangement of apparatus used to show reaction of zinc granules with dilute sulfuric acid and label hydrogen gas bubbles. So here what we have to do, we have to first draw the diagram of reaction of zinc granules with dilute H2SO4, that is sulfuric acid, and then we have to label hydrogen gas bubble. So this is the diagram which is from your NCERT book. I hope you know this. This diagram is very important. Many of the times this diagram has been repeated. So you have to practice this diagram. So this is the diagram from NCERT book. Here, so you can see the diagram. This is a stand. Then for this stand, here there is a clamp to which one test tube is fixed. And from this test tube we have a rubber cork with the bent capillary, or it is also called as delivery tube. This delivery tube will enter into the beaker in which there is a soap solution. And here we have taken a candle. So what is done here? In this test tube, we are going to take zinc granules and dilute sulfuric acid. Once you mix zinc granules and dilute sulfuric acid, zinc will react with sulfuric acid and we will get zinc sulfate and hydrogen gas is liberated. That liberated hydrogen gas will move from this capillary and it will enter into the soap solution. Once this hydrogen gas enter with the pressure in the soap solution, that hydrogen gas will form like this bubbles, and near these bubbles when we bring this burning candle, it's get off by making pop sound. So whenever pop sound comes and if the candle get off, you should understand that the gas present in the bubbles is hydrogen gas. So the reaction which takes place here is zinc plus sulfuric acid, that is H2SO4, and here we will get a salt, that is zinc sulfate, and hydrogen gas is liberated. So H2 hydrogen gas is liberated, and this hydrogen gas, the liberated hydrogen gas will form these bubbles which you can see here. So this is only we have to label. So what you have to label is this one. So this is your answer. Remaining all labeling also you have to remember, because in model question paper 1 they have asked this labeling, in model question paper 2, 3, 4 or in final exam they may ask the other labeling. So you have to practice all the labelings every time, but in exam you write whatever they have asked. So this is the answer for question number 19. Now the next question, question number 20, which is again consist of A and B. We will start with A. Name the salts responsible for the hardness of water. So water can be hard or water can be soft, like sea water or well water will be hard water and rain water will be a soft water. So what is hard water? Hard water is nothing but the water which will not give foam or lather easily with the water, soap. That is called as hard water. And the water which gives foam easily with the soap is called as soft water. So why hard water will not give lather with the soap? It is just because of the presence of salts. So which are the salts responsible, that we have to write here. So the salts are bicarbonates, sulfates and chlorides of calcium and magnesium. So bicarbonate means some of the examples we can give, like calcium bicarbonate. The formula is CaHCO3 twice. Then we can write magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. So as I have written here, bicarbonates of calcium and magnesium. So these two are bicarbonates of calcium and magnesium. Then sulfates. So calcium sulfate and magnesium sulfates are the sulfates, and chlorides means calcium chloride and magnesium chloride. So this is the answer for question number 20. A. Now the B question, next question. Write the name and molecular formula of the simplest hydrocarbon. So here we have to write the example or name and molecular formula for simplest hydrocarbon. So first we will see what is hydrocarbon. So hydrocarbon. So what is hydrocarbon? See, the word indicates it consists of two words. One is hydro and second one is carbon. Hydro is nothing but hydrogen and carbon is nothing but, as usual, carbon. So hydrocarbon are the compounds which consist of or which made up of hydrogen and carbon are called hydrocarbon. So we have to write the simplest hydrocarbon. Simplest means what? The hydrocarbon which has only one carbon. So if I take one carbon, as we know carbon valency is 4, carbon can form 4 bonds. So I'll write it here 4 bonds. Then I'll write it hydrogen, hydrogen, hydrogen and hydrogen. So this is nothing but what? It is nothing but condensed formula I can write as CH4. It is nothing but methane. So that is only the simplest hydrocarbon. So here methane is the answer for this question. And what you have to write? The simplest hydrocarbon is methane with the molecular formula CH4. It consists of one carbon atom single bonded to 4 hydrogen atom? This is the answer. You have to write 2 lines and then draw these structures. Now we'll move with the next question. Now the next is question number 21. Draw the diagram to the arrangement of the apparatus used in the electrolytic refining of copper and label cathode. So the question is, you have to draw the diagram of electrolytic refining of copper. What is electrolytic refining? This is the method which is used in metal extraction and where we can get the 100% pure metal. So here we have to draw the diagram of this. So this is the diagram from NCERT book. You can see. So this is nothing but an electrolytic cell. So it consists of 2 electrodes. This is one and this is another. These are the 2 electrodes, and these 2 electrodes are dipped in a solution which is called as electrolyte. So here the electrolyte used is acidified copper sulfate, and then here as it says electrolytic, electro means you have to use the current, so this is the battery and here it is the key. So now this is the diagram of electrolytic refining. In this, what we are going to do, we are going to take one electrode as anode and one electrode as cathode. So anode will be always impure. So here our anode will be always impure. So this is impure and cathode will be always pure. So what happens? At anode, one reaction takes place which is called as oxidation, and the metal ions will go and deposit at the cathode by the reaction called reduction. And like this, we can separate our metal from the impure metal. And this is called electrolytic refining. So here the question is, you have to label cathode, and this is the answer. You have to write this side cathode. So this is the answer. So here remember all the labelings, because as I told, in this model question paper they have asked label cathode, but in next model question paper or the final exam they may ask anode, or they may ask impurities, or they may ask acidified copper sulfate means electrolyte. So remember all the labelings. Now the next is question number 9. Answer the following questions, and here we have to answer 3 questions. Each question carries 3 marks, so 3 3s are 9. So total marks we are going to get from this section is 9. So we'll start question number 12. Write the balanced chemical equations for the following word equations. So here we have got word equation and we have to convert those word equation into a balanced chemical equations. So we'll start first one. Manganese oxide plus hydrochloric acid gives manganese chloride plus chlorine plus water. So first convert this into its symbols. So manganese oxide means it is MnO2. Hydrochloric acid formula is HCl. When we add these two, we are going to get manganese chloride, MnCl2, then chlorine and water. So here I have written H2O and chlorine, that is Cl2. Now they have asked balanced chemical equation. So we have to balance it. What is balancing? The number of atoms present on left hand side should be equal to the number of atoms present on right hand side. And that reaction is called as balanced chemical equation. So we will start balancing the reaction. So here we will write atoms. Here we'll write LHS. LHS means left hand side. And here we will write RHS, that is right hand side. So this is our LHS and this is our RHS. So here I will write RHS and here this is our LHS. So if you use this method for balancing, it will be very easy for you. So start writing which are the atoms we have. We have Mn, it is manganese. Then we have oxygen. Then we have hydrogen and we have Cl. Now write down number of atoms present at left hand side and right hand side. So Mn, how many are there on the left hand side? It is 1. Then oxygens, how many are there? It is 2. Hydrogen 1 and Cl, it is only 1. Then go right hand side, see right hand side, Mn is again 1. Then oxygen, it is 1. Then hydrogen, it is 2. You can see 2 hydrogen in H2O. And chlorine, Cl, it is total 4 we have. 2 from MnCl2 and 2 from Cl2. So this is the condition. Here if you see Mn, both the side it is balanced, and oxygen it is not balanced, hydrogen also it is not balanced, and even Cl is not balanced. So this we have to start balancing. So Mn we will not balance because it is already balanced. We'll go for oxygen. So oxygen, if you see left hand side we have 2 oxygen, right hand side we have 1 oxygen. So we can convert this 1 into 2 by multiplying with 2. So 1 into 2 will be is equals to 2. So like this we have done oxygen equal on left hand side as well as right hand side. So this 2 we will substitute in our reaction. So where is oxygen? Oxygen is in water. So I'll write it here 2. So I wrote 2. But because of this 2, hydrogen also changed. Hydrogen became 2 to the 4. So on right hand side, I have written hydrogen 2, which is earlier, but because of balancing oxygen, now it became 4. So we will make this 2 as 4. So I'll write it 4 hydrogens on the right hand side. Now oxygen also it is balanced. Now go for hydrogen. Hydrogen right hand side we have 4, left hand side we have only 1. So to make it 4, multiply by 4 on left hand side, so it will become 4. So I will substitute this 4 in our left hand side. So I wrote it 4. Now by writing this 4, you can see here on LHS side, Cl also has got change. Cl earlier it was 1, now it became 4. So therefore I will make it 4. Now see, hydrogen is already balanced, and because of writing 4, Cl also has got balance, and with the help of this our whole reaction has balanced. So our first balanced reaction we can write it here, that is MnO2 plus 4HCl gives MnCl2 2H2O and we got Cl2. So this is our balanced first reaction. We'll move with the second reaction. So see the second reaction, calcium hydroxide plus carbon dioxide gives calcium carbonate and water. So first convert this word equation into its symbols. Calcium hydroxide is CaOH twice, carbon dioxide is CO2. It gives calcium carbonate, that is CaCO3, and water, it is H2O. So same like earlier, write down first number of atoms on left hand side and right hand side. So I'll write it here, atoms, then this is LHS, this is RHS. So what are the atoms we have? We have calcium, oxygen, hydrogen and carbon. So write down on LHS we have only one calcium, oxygens we have total 4. So these are 2 and here we have again 2. So total 4 oxygen. Hydrogen we have 2, carbon we have 1. Now go to RHS. Calcium we have 1, oxygen we have 4, 3 from CaCO3 and 1 from water. Then hydrogen we have 2 and carbon we have 1. So if you see this table, calcium both the side it is 1 1 balanced, oxygen 4 4 balanced, hydrogen 2 2 balanced, even carbon it is 1 1 balanced. So this reaction is already balanced, no need to balance the reaction. We'll write it. So our equation is CaOH twice plus CO2 and then we are getting CaCO3 plus water. So this is our balanced chemical equation. We'll move with the third one, that is zinc carbonate gives zinc oxide plus carbon dioxide. Convert this into a symbolic form. Zinc carbonate is ZnCO3. You can see this. Zinc oxide is ZnO and carbon dioxide is CO2. So write down all the atoms in the table. So atoms, this is LHS and this side it is RHS. So write down atom, we have zinc, we have carbon and we have oxygen. Zinc on LHS side it is 1, RHS side also it is 1, carbon on LHS side it is 1, even on RHS side it is 1, oxygen here it is 3, and this side 1 from ZNO, 1 from CO2, so total again 3. So if you see zinc 1 1 balanced, carbon 1 1 balanced, oxygen also 3 3 balanced. So this reaction is also already balanced. No need to balance this equation. So write down the final equation. ZnCO3 gives ZNO plus CO2. So this is our final equation. So like this three reaction you have to write for all three equations, word equations. So here you should know the formula first. If you know how to write zinc carbonate, if you know how to write calcium hydroxide or these all the formulas, then the writing reaction is very easy. Already we have studied in our earlier classes 9th standard how to write this formula. You should know the oxidation number of each ion. If you know the oxidation number, then easily you can write the formula. For example, I will show you one how to write the formula. We will take CaOH twice. So see how we got this formula, that is calcium hydroxide. So we will take Ca oxidation state is +2, OH oxidation state is -1. So if you cross these, then this 1 comes on Ca side, so Ca will be 1 and 2 goes on OH side. So OH we have to write in bracket and then write the 2. So like this we can write the formula of all the compounds. So you should know the oxidation states of every ion. This is the answer for question number 22. Now we'll move with the next question. Now the next OR question, that is convert the following chemical reactions into chemical equation. Earlier question and this question is little bit same. In earlier question we had a word equation and we converted into chemical equation. Now we have a reaction in the form of sentence and we have to convert it into a chemical reaction, chemical equation, and we have to balance it. So the first one, ammonia forms when nitrogen gas reacts with hydrogen gas. So by reading this sentence, first find out which are your reactant and which all are your product. So here you can see ammonia forms, means ammonia is your product. Nitrogen and hydrogen reacts, means these are your reactant. So you should know the symbols of this. Take those symbols and then you can prepare your reaction. So here hydrogen symbol is H2, nitrogen symbol is N2 and ammonia, the symbol is NH3, formula is NH3. So I took here N2, I took here H2 and then this is our NH3. So this is the reaction where nitrogen combines with hydrogen, reacts with hydrogen to give ammonia. Now we have to balance this. So as I told earlier, write down. So I took here atoms, then this side is LHS, this is here RHS. Write down the atoms. We have nitrogen and hydrogen only 2. Nitrogen on the left hand side it's 2, but on right hand side it is 1. Hydrogen on left hand side it is 2, on right hand side it is 3. So both are not balanced, so we have to balance it. So if you see nitrogen, LHS side it is 2, RHS side it is 1, so you can make it 2 by multiplying with 2. So I will multiply with 2, so it will become 2. Substitute this 2 into your reaction. So nitrogen on RHS side we are going to write it 2. So I wrote here 2. When I wrote here 2, hydrogen also changes. So hydrogen earlier it was 3. Now by writing 2, 3 2s are 6. So on RHS side hydrogen became 6. So write out this. So I'll remove that 3 and then I'll write it here 6. Now if you focus, hydrogen RHS side it is 6, on LHS side it is 2. How to make it 6 now? Multiply with 3. So 2 3s are 6. So now write this 6 on LHS side. So hydrogen, and here we have to write it 6. So 6H2. Now you can see nitrogen LHS side, RHS side 2 2. Hydrogen LHS side, RHS side it is 6 6. Now the reaction is balanced. So balance reaction, I will write it here. So how to write it? It was N2 gaseous state plus 6H2 gaseous state, and it gives 2NH3 2NH3, and this is again a gaseous state. So this is our balanced chemical equation for the first question. Now we'll move with the second one. The second one is sodium oxide reacts with water to form sodium hydroxide. So sodium oxide reacts with water, means these two are our reactant and sodium hydroxide is our product. So write down the symbols of this formula of this. Sodium oxide is nothing but Na2O, water is H2O, and sodium hydroxide is NaOH. Now we have to balance it. So write down here atoms. This method is very easy to balance any chemical reaction. Then I'll write it here RHS. So write down the atoms. We have sodium, we have oxygen, and we have hydrogen. So LHS side sodium are 2, RHS side it is 1, oxygen LHS side 1 from Na2O and 1 from water, so it is 2. On RHS side it is 1. Hydrogen on LHS side it is 2 from water and 1 from NaOH. So if you see, all three atoms are not balanced. So we have to balance it. First we will start with sodium. On LHS it is 2. So on RHS side we will multiply by 2 and we will make it 2. And we will write these 2 in our equation. So I wrote it here 2. Because of writing these 2, oxygen on RHS side and even hydrogen on RHS side changed. So we will make those changes in our box. So I'll write it here oxygen 2, hydrogen 2. Now if you see your table, sodium on LHS, RHS both the side it is 2, 2. Even oxygen it is 2, 2 and hydrogen also it is 2, 2. So here our reaction is balanced. So we will write the balanced chemical equation. It is Na2O solid plus H2O liquid, and it gives 2NaOH, and this is again aqueous. So this is our balanced chemical equation. Now we'll move with the third one. So the third one is, by reacting with water, potassium metal provides potassium hydroxide and hydrogen gas. So you have to read it very carefully. By reacting with water, potassium metal, means potassium metal is going to react with the water. So these two are our reactant, and it produce, means our product, potassium hydroxide and hydrogen gas. So write down their symbols. Potassium it is K, water H2O, potassium hydroxide is KOH, and hydrogen gas it is H2. So now balance the reaction. So I'll write it. So it is atom, then LHS, and then here it is RHS. So the atoms are, we have potassium, we have hydrogen and oxygen. LHS side potassium is 1, RHS side also it is 1. Hydrogen on LHS side it is 2, RHS side it is total 2 plus 1, 3. Oxygen it is 1 and this side oxygen is 1. Now to balance potassium, we have 1, 1, no need to balance. Hydrogen we have to balance because hydrogen on RHS side it is 3 and on LHS side it is 2. So if you multiply, if you want to make it same, then if I multiply this side with 3, it will become 6. Then on RHS side if you multiply with 2, it will become 6. So like this if you do, it will be balanced. So there will be some reactions where on both the side we have to multiply. So we have to see it very carefully. So this is also now balanced. Now write this number, that is 3 and 2 on both LHS and RHS side. So on LHS side we have multiplied by 3. So I'll write it here 3 in front of H2O. and on RHS side I have multiplied with 2. So here we have to write this 2. So by this method we are not able to balance this reaction. We will make little bit of changes in this. So here what we'll do, we are not able to balance by that method. So we will divide this and we'll write one side KOH and one side we'll write H2. We will balance it separately. Hydrogen H2 we have 2, so write 2 as it is. On KOH side we have hydrogen 1. So what we will do, 1 we will multiply by 2, so it will become 2. So total 2 plus 2 will be 4 hydrogen on this side, and to make it 4, here we will multiply with 2 and this also we will make it 4. So hydrogen on left hand side we have multiplied with 2, therefore we will replace this 3 with 2. So we will write it here 2. So 2H2O. Now, because of writing here 2H2O, 2 2s are 4 hydrogen, and this side I wrote 2, so I will write it this also 2. So because of writing this 2, here potassium also got changed, so potassium became 2, so that's why I will write it 2. Now to balance potassium on LHS side also I will multiply with 2, so it will become 2. So write this 2 on the LHS side, so this side of 2. So now if you observe, oxygen also has got changed, that is LHS side it became 2. So this is also 2. Even on RHS side it became 2, so here also it is 2. So this is a trial error method for balancing this third reaction. I hope you understood. It is easy, just you have to practice. If you practice some of the reactions, then you will feel easy to balance the reactions. So the balanced reaction, I can write it here. So the reaction is 2K solid plus 2H2O liquid, which gives 2KOH, that is aqueous, plus H2 gas. So this is our balanced chemical equation. So this is the answer for this OR question. I hope you understood. Practice some of the reactions, you will feel easy to balance all the chemical equations. Now we'll go with the next question. Now the next question, question number 23. 4 solutions A, B, C and D when tested with universal indicator showed pH 5 to 7 and 11 respectively. Which solution, first question, has more hydronium ions? Second is neutral, and third is the weak acid. So understand the question first. We have 4 solutions A, B, C and D, and we are going to test these solutions with universal indicator, which will show the pH 5 to 711. Depending on this, we have to answer these 3 questions. So universal indicator means what? It is the indicator which gives color depending on the presence of H plus ion. And also it is called universal because it is the mixture of indicators and which gives different type of colors depending on the H plus ion concentration. So here we will start the first question. Before going to the first question, we will see little bit extra information about this question. So if you see this diagram is from again NCERT book. So here we know that we have a pH range that is from 0 to 17, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So this is our pH range. In this pH range, 0 to 6 is called as acidic and 8 to 14 is called as basic. And here this 7 is called as neutral. So acidic range is from 0 to 6. Means here hydrogen ion concentration will be very high. Basic means 8 to 14. Here OH minus hydroxyl concentration will be high, and in terms of H plus it is low. And at neutral, H plus and OH minus both will be equal. That is called as neutral. So the same diagram here I have drawn. If you see, this is 0. 0 means H plus concentration is more. And as we move from 0, 1, 2, 3, 4, 5, 6 till 7, H plus ion concentration will be go on decreasing. Decreases. H plus concentration, I'll write it here, concentration decreases. And from 7 to 14 if you see, H plus will decrease and OH will increase. So I'll write it here, OH minus will be more. And here if I see, OH minus will be less. And here H plus will be less. So this you should remember. If it is 0 pH, H plus concentration will be high. As you go forward 1, 2, 3, 4, 5, 6, H plus will be less because OH is increasing. Starting at 8, OH will be less, but at 14, OH minus will be more. So here if you see this diagram, this acidic nature increasing this side because here it is neutral, and this side basic nature is increases. So blue color indicates here acidic nature, and this blank indicates here this basic nature. So, and one more thing, here if you see the first question, has more hydronium ions they are asking. Hydronium ions means H3O plus. H3O plus is nothing but it is equal to H plus ion. H plus ion are not available as H plus. They will immediately combines with water and it will exist as H3O plus ion, which is called as hydronium ion. So H3O plus is nothing but what? H plus ion. So this we have to remember. Now see the first question. Has H3O plus ion they are saying. H3O plus ions are more, means H plus ions are more. If H plus ions are more, if you see this diagram, it will be acidic. And if it is acidic, its pH should be from 0, 1, 2, 3. So if you see your question, here it is 2. So 2 is the answer for first one. See the second one, it is neutral. We know neutral. Neutral the pH will be always 7. So we will write 7 as the answer for second one. See the third one, it is the weak acid they are asking. Weak acid. If it is more H plus, then it will be strong acid. This is strong acid. If it has less H plus, it will be weak acid. You have to remember this. If it is less OH, then it will be weak base. If it has more OH, it will be strong base. So according to this, weak acid means H plus should be less, and if it has less H plus, then its pH should be somewhere near to 7, and that's why if we have 5 as the number which is near to 7, so I wrote the answer 5. So this is the answer for question number 23. I hope you have understood. I have explained it very neatly. You have to remember these tricks which I have written. H plus more, strong acid. H plus less, weak acid. OH minus less, weak base. OH minus more, strong base. Like this, one or the other question will come in your exam. Always it will be asked. So you have to remember this trick. You can answer any type of questions depending on this pH. Now we'll move with the next question. Now the question number 24, which is again divided into A and B. We will start with A. Explain the formation of sodium chloride, that is NaCl, molecule by the transfer of electron. So we have to explain here formation of sodium chloride. Sodium is a metal and chloride is a non-metal. So transfer of electron from metal to non-metal we have to explain with the help of sodium chloride. So answer, here I have written all the notes. So I will read these notes once and then we will see how sodium chloride is formed. First point, sodium atom has one electron in its outermost shell. So if you see the diagram, sodium atomic number is 11. It will be distributed like K shell 2, L shell 8 and M shell will have one electron. So therefore outermost shell will be M, so it has only one electron. If it loses the electron from its M shell, then its L shell now becomes the outermost shell and that has a stable octet. Very important. So take sodium whose atomic number is 11. So if you write the electronic configuration, that is K, L and M and N shell, then first shell will take 2 electrons, then remaining will be 9. L shell will take 8 electrons, remaining 1 will go to M shell. Now presently here M shell is the last shell. So now what this sodium will do? Sodium loses one electron. You can see here, sodium loses one electron from its M shell. So this sodium, if it loses this one electron from M shell, then the last shell will be L. I hope you are understanding. Then the last shell will be L and L shell has already 8 electrons. Means it has attained octet. So it is a stable electronic configuration. Now see the second point. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So there is a net positive charge giving us sodium cation. So we can see here atomic number was 11, means it has proton 11 as well as electron 11, but we have removed one electron. So protons are 11 only, but electrons became 10. Protons are more and therefore sodium will get a net positive charge, which we can write it as Na+. Now if you see chlorine, chlorine has 7 electrons in the outermost shell and it requires 1 electron to complete its octet. So if I take chlorine now, chlorine atomic number is 17, means 17 proton, 17 electron. Write down the electronic configuration K, L, M and N. So 2, 8, 10 and then it becomes 7, 17. So now the last shell is 7th one. That is last shell is, outermost shell is the M shell. If it take 1 electron, it will attain octet rule, it will complete its octet and it will attain a stable electronic configuration. So it will, if it takes 1 electron, it will become 8. So this electron which Cl takes to attain octet, that electron is coming from sodium. So sodium here loses 1 electron and that electron will be gained by chlorine. So here after gaining the electron, here the number of electrons will become 8 in the last octet. So total electron will become 18. But the protons will remain 17 itself, because in this 17 protons are there and 17 electrons are there. But we have added one more extra electron. So electron became 18 and proton remains 17. Because electrons are more, Cl will get net negative charge and therefore Cl will be written as Cl-1, that is called as chloride anion. Now the next, sodium and chloride ion being oppositely charged attract each other and are held by strong electrolytic forces of attraction to exist as sodium chloride. So now what happens? Here we got Na plus, and from this process we got Cl minus. So this is positive charge, this is negative charge, and they both will attract each other and both will get held by a strong electrolytic force, and then we get our sodium chloride. And this is only explained here. So this is of sodium and this is of Cl, and here by the strong attraction between the positive and negative we get this sodium chloride. So for this question they have asked explain. Explain means you have to write these steps as well as you have to write this explanation for this sodium chloride. So this is the answer for 24th A question. Now we'll move with the B question. So the question is, what are the products obtained when aluminium metal reacts with steam? So here, as we know, metals reacts with oxygen, metals reacts with water, but there are some metals which will not react with water in liquid state. They react with water in a gaseous state. Water in gaseous state means what? It is nothing but a steam. So aluminium is one of the metal which will react with the steam, that is water in gaseous state. So here when aluminium combines with water, that is steam, it gets converted into aluminium oxide and hydrogen gas is liberated. So aluminium oxide is nothing but what? Al2O3 and hydrogen gas, that is our H2. So this is the reaction which we have to write for this question. What are the product they are saying? So the products are aluminum oxide and hydrogen. Here we can write the name of the product also. So write down our product. Say product aluminium oxide, and the second product is hydrogen gas. So these are our products. So now the next OR question from this. Again, OR question is divided into A and B. This is A and here it is B. First we will start with A. Explain the formation of magnesium chloride molecule by the electron transfer. This question is same like earlier. Earlier we have done for sodium chloride and now it is for magnesium chloride. So in the same way we have to explain. So I'll read the points first. Magnesium atom has 2 electrons in its outermost shell. If it loses the electrons from its outermost M shell, then its L shell now becomes outermost shell that has stable octet. So now we'll consider magnesium. Magnesium atomic number is 12, means it has protons 12 as well as electrons also 12. Now we'll write the electronic configuration for this. So I'll take K, L, M and N shell. So 2 electrons, then 8 electrons, and then M shell will get 2 electrons. So this is the outermost shell or the last shell. It has 2 electrons. So this magnesium will lose these 2 electrons and it becomes Mg plus 2. So see here what happens when it loses these 2 electrons. Now this L shell will become the outermost shell and it has already 8 electrons, means it has completed its octet. So it has attained stable electronic configuration. And for this magnesium has to lose these 2 electrons. Now see the next. So the next point is the nucleus of this atom still has 12 protons, but the number of electrons has become 10. So there is a net positive charge giving us a magnesium ion. So it should be here magnesium. So what happens? Net positive charge giving us magnesium cation, that is Mg plus 2. So as I told, protons are 12 and now because of losing 2 electrons, electron became 10. So if you see, number of protons are more, therefore Mg will get net positive charge and Mg becomes Mg plus. and how many electrons it has lost? 2. So therefore Mg plus 2. Chlorine has 7 electrons in its outermost shell and it requires one more electron to complete its octet. So as I have discussed earlier, Cl atomic number is 17. It has proton 17 and as well as electrons also 17. Electrons also 17. So if we write the electronic configuration K, L, M and N, then it will be 2, here it will be 8 and here it will be 7. So M is the last shell, outermost shell, which has 7 electrons, and to complete the octet it requires 1 electron. So Mg is losing 2 electrons and one Cl can take 1 electron. It can take 1 electron. So what we are going to do? We are going to take 2 Cl. So this is 1 Cl. We will take one more Cl and this also can take one more electron. And therefore Mg combines with 2 Cl ions, 2 chloride ions to give MgCl2. We'll move with the next. Electron lost by magnesium could be taken up by 2 chlorine. After gaining electrons, the chlorine atom gets unit negative charge because its nucleus has 17 protons and 18 electrons in its K, L and M shell. This gives us chloride ion, that is Cl minus ion. Magnesium and chloride ions, being oppositely charged, attract each other and they held by strong electrolytic forces of attraction to exist as magnesium chloride. So as we have discussed earlier, so here what happens? Proton will remain 17, but electron, because of addition of 1, it will become 18 and Cl gets net negative charge, that is Cl becomes Cl minus 1. So what happens here? Magnesium and chloride are oppositely charged because Mg is Mg plus 2 and Cl is Cl minus 1. Because of oppositely charged, they get attracted towards each other and they form a strong electrolytic force to form magnesium chloride, that is MgCl2. So here this is the diagrammatic explanation for this. So here you can see Mg will become Mg plus 2, Cl will become Cl minus. So 1 Mg loses 2 electron. 1 electron goes to 1 Cl, another electron will go to another Cl. So it becomes Mg plus 2 and Cl minus, it is 2 here and it gives MgCl2. So this is the explanation for this question. Now the next question, that is question B. How is pure zinc obtained from zinc oxide? So we have to obtain a pure zinc from its ore, that is called as zinc oxide. Zinc oxide is nothing but ZnO. So the answer is the metal oxides are reduced to its corresponding metals by using suitable reducing agents such as carbon. So what are reducing agents? Reducing agent means these are some chemicals which will reduce the ore into the pure metal. It may be oxide, it may be chloride, it may be any ore. It removes the impurity and only convert it into a pure metal. The suitable reducing agent is carbon. Carbon is used as mostly a reducing agent for many of the reactions. So for example, here they have asked zinc from zinc oxide, so that we are going to take. Zinc oxide is heated with carbon, it is reduced to metallic zinc. So you can see the reaction. ZnO is nothing but zinc oxide. This is our carbon. So what carbon is doing? Once you react these both, carbon will go and take this oxygen and it becomes CO, that is carbon monoxide, and zinc will separate as it is. So here it was zinc oxide, now it has reduced, it has decreased to only zinc. So this is done by carbon and that's why it is a reducing agent. Agent means which is helping for the reaction. So carbon is helping us to convert this zinc oxide to zinc. That's why it is called as reducing agent. So this is the answer for question B. So I hope you understood this questions of this explanation. Now we'll move with the next question. Now question number 10. Answer the following questions. Here we have to answer one question which carries 4 marks. So total marks we are going to get from this section, it is 4. Question number 25, which is divided into A and B. First we will start with A. Write the structures of N-butane and isobutane. So we have to write the structure of N-butane and isobutane. But means it is 4 carbon, but in the same 4 carbon compound they have asked N-butane and isobutane. So answer, N-butane, a straight chain of 4 carbon compound. So always remember, as I told, but means it is 4 and N indicates it's a straight chain. So this is a straight chain compound. For this is the structural formula. This is the structural formula, and here I have written condensed formula, means combining all the hydrogens together, the formula written which is called as condensed formula. So this is the formula for N-butane. So here I'll explain you once again. So we should take 4 carbons like 1, 2, 3 and 4, and it is butane. Butane, A-N-E, indicates all carbon have single bond. So here all carbons have single bond. So remaining all the valency of carbon you have to adjust by writing hydrogen. So first carbon will get 3 hydrogen, second carbon will get 2 hydrogen, third carbon will get 2 hydrogen, and fourth carbon will get 3 hydrogen. So like this we will balance the valency of each carbon, and this is the structural formula of N-butane. It is a straight chain compound. Now what condensed means? Condensed means first combine this all 3 hydrogens with the carbon, so it will become CH3. Then combine this 2 hydrogen with this carbon, so it becomes CH2. Same way for this carbon, it becomes CH2, and the last one, that is this carbon, so this will become CH3, and this is only called as condensed formula. So this is the answer for N-butane. Now we'll move with the isobutane. So isobutane means what? Isobutane, it is a branched structure with the main chain of 3 carbon atoms and 1 carbon atom branching off the middle carbon atom. So what here we have to do? First we have to take 3 carbons, and for the middle carbon we have to branch with the 4th carbon. So total carbon present in butane are 4, but in main chain we have to take only 3 carbon, and remaining 1 carbon we have to branch it to the middle carbon. Then it is called as isobutane. So this is a structural formula and this is a condensed formula. So we will see it in a detailed way. So as I told, first take 3 carbon, 1, 2, and this is 3 carbon. Now for middle carbon we have to branch it. So I'll write it another carbon, 4th carbon. Now we have to balance the valency. So if you see first carbon, it require another 3 bond. So I'll write H, H and H. Middle carbon, if you see, it has 3 bond, 1, 2, and this is third one. Fourth one we will write H. If you see the last carbon, this also requires 3 hydrogen like this. And if you see the branch carbon, it has 1 bond, it requires another 3 bond like this. So we will write H, H and H. Now if you see, this is the structural formula for isobutane. Now same thing we can write it like this. You combine these all, it will become CH3. Then first you combine this, it becomes CH. It is a chain. For this carbon we have, this is a branch, that is CH3. So I'll write CH3 as it is. And then I will combine these all together and write it as again CH3. So like this way we will get this formula for isobutane. The same structure which I have drawn here, that is a formula, condensed formula, still we can condense it. Still we can make smaller, and that is nothing but the formula which is written here. So how it is done? So first write the main CH3. I will write it here above. So I'll write CH3, which is this one. Then the bond, that is this second next bond, CH as it is. So I wrote CH as it is. The CH3 which is branched here, that we can write it in a bracket beside this CH. So CH3, then bond, and again remaining CH3. So this is also called as condensed formula. So this blue colored which I have written, that is also condensed, and still it condensed means this is the black color which I have written. So these are the formulas of isobutane. So remember, this is also isobutane, this is also isobutane, and this is also isobutane. This is a structural formula and this one is a condensed formula. So remember, iso means branched. You have to first take a main chain and then you have to branch it, that is called isobutane. If you branch it to the middle carbon, it is called as isobutane. And if you have a compound which is straight chain, then it is called as N-butane. But means 4. If you take N-pentane, then straight chain will have 5 carbon. Now it is N-butane, so straight chain will have 4 carbon. So this you have to remember. Now in this question paper they have asked N-butane. In next question papers or in final exam they may ask for pentane, they may ask for hexane or propane, etc. But you have to remember the method how to write the formula. Now it is question B. What is esterification? How ethene is obtained from ethanol? So first we will write definition of esterification. It's a chemical reaction in which carboxylic acid reacts with alcohol to form ester and water. So it's a reaction, it's a process where we are going to prepare ester by using carboxylic acid and alcohol. This reaction is typically carried out by heating the mixture in presence of acid catalyst. So here we are going to heat carboxylic acid and alcohol in presence of a catalyst which is called as acid. Nothing but it is a concentrated sulfuric acid. So if we write the reaction of this esterification, it will be like this. So we take ethanoic acid as carboxylic acid. So I'll write it here CH3COOH. So this is our ethanoic acid and this we will react with ethanol, that is CH3, CH2 and OH. So this is ethanol, and when we will react these two in presence of acid, so I'll write it here acid, we get ester. So ester formula will be CH3, C double bond O, this is the functional group of ester, and then it will be CH2 and CH3 plus water will be a byproduct. So this is our reaction of esterification. If you see this reaction here, this hydrogen and this OH combines with each other and gives water, that is this, and remaining all will combine to give this ester. So I'll write it here ester, I'll write it here ethanol, and this I will write it as ethanoic acid. So this is ethanoic acid. So this is the reaction of esterification. Now the next is we have to explain ethene formation from ethanol. So see here, ethene is obtained from ethanol through dehydration reaction. So what is dehydration reaction? The reaction in which water is removed, that is called dehydration. So ethanol, when heated with excess of concentrated sulfuric acid, here concentrated sulfuric acid act as dehydrating agent. Means when you heat this ethanol in excess of this acid, this acid will help to remove the water molecule from this alcohol, and that's why it is called dehydrating agent. And then we will get ethene. Ethene means what? Ethene means it's the two carbon compound consist of carbon-carbon double bond, that is nothing but alkene. So that only we have to explain it here. So the reaction of this can be given like this. So see here, C2H5OH is nothing but ethanol, that is alcohol. And when you take concentrated sulfuric acid and heat it till 170 degrees Celsius, this will become C2H2, that is ethene, and water will be removed. This reaction also can be explained in detail. I'll write it here. So we will take this C2H5OH like this, split it and write the whole structure. So see here, this is nothing but C2H5 and this is our alcohol group. Here we are going to take concentrated H2SO4 and heat it till 170 degrees Celsius. So this is temperature, and here we will get C double bond C and H4. So like this I can write H4. So if you see in this reaction what happens, this H and this OH will combine to give water, and here I will write that water. See this water. And remaining all will be as it is, that is CCHH. But to balance the valency, carbon-carbon will get here double bond, and due to this only it will become ethene. So this is ethene and this was ethanol. So in this reaction, this H2SO4, due to the presence of this concentrated H2SO4, we are able to remove this water. So this is called as dehydrating agent, and the whole reaction is called as dehydration reaction. So this is the answer for question B. Now we'll move with the next question. Now the next, that is OR question. It is again divided into A and B. We will start with A. Write the dot structures of nitrogen and propyne molecule. So here the question is, we have to write the dot structure, electron dot structure for nitrogen and propyne. Nitrogen is nothing but N2 molecule, and propyne is nothing but the compound having 3 carbon and 1 triple bond, that is called as propyne. So we will start with nitrogen first. Each nitrogen atom has 5 valency electrons. So atomic number of nitrogen is 7. If you distribute in a shell, we will get 5 valency electrons. The two nitrogen atoms share 3 pairs of electrons to complete its octet and forms triple bond, that is N triple bond N. Each nitrogen atom also has 1 lone pair of electrons, and therefore the structure is represented like this. So detailed explanation for the structure can be given like this. So as I told, nitrogen atomic number is 7 and electronic configuration will be K, L, M and N if you take these shells. So K will take 2 electron and L will take 5 electrons. So total will be 7. So if you see here, this L is the last shell or outermost shell, and valency electrons in this will be 5. If you arrange this valency electron, if you see this valency electrons, it requires another 3 electrons to complete its octet, and therefore one nitrogen will share 3 electrons with the another nitrogen. So it will be shown like this. So if I write one nitrogen here and write its valency electrons 1, 2, 3, and remaining 2 I will write at the side, because 3 middle, these are going to share with the another nitrogen. So I'll write it here 3, and this is one more nitrogen. Now each electron will be shared with another nitrogen. So like this, here it will share, like this here it will share, and this is also will be shared. So total 3 bonds will be formed between 2 nitrogen, N, 1 bond, 2 bond, 3 bond, and this is another nitrogen. So as you can see here, there will be one lone pair, and sorry, as usual here also there will be one lone pair. So this is the lone pair. So this is the dot structure for nitrogen molecule. Now if you see for propane, so in propane this molecule has 3 carbon atoms and 8 hydrogen atoms. Sorry, it will be having 4 hydrogen atoms because carbon-carbon has one triple bond because it is wine, propyne, YNE is nothing but triple bond, alkyne. So the total valency electrons will be 4 into 3 and 8 into 1. If we add, there will be total 20 valency electrons, and these all 20 valency electrons we have to adjust in this propyne. The carbon atoms are bonded in a single chain. It has one single bond and one triple bond. Each carbon atom forms single bond with the remaining hydrogen atoms. So therefore the structure of this will be, so we'll write the structure of this. So I will take 3 carbon, 1, 2 and this is 3. As I told, it is propyne, alkyne. 2 carbon atoms should have triple bond. So for every carbon there will be 4 valency electrons. So what I will do, I will write it here 3. This is the 3 electrons of this carbon. 1 will be right this. So these are 4 valence electrons of this carbon. These are the 4 valence electrons of this carbon, and for last carbon I will write separately its 4 valency electrons. Now see what happens. Now this and this will be shared, this and this will be shared, this and this will be shared. So here we got a triple bond, this will be shared, here we got a single bond, and remaining all will be balanced by the hydrogen. So this can be written like this. So this is H, electron, electron, C, electron, electron, C, electron, electron. So these all write as it is shown. This is H and here it is H, here it is H. So this is 1, this is 2, this is here, where it will be. So like this you can show the bond formation. So this is called the structure, dot structure of propyne. So if you combine, it will be CH3, single bond, C, triple bond, CH. So this is nothing but propyne. 3 carbons means prop and triple bond means ine, that is propyne. So this is the dot structure of propyne. So I hope you understood this. Now we'll move with the B question. Question B. Explain cleansing action of soap on dirt. So we have to explain how the soap will clean the dirt. First point. Most dirt is oily in nature, and as you know, oil does not dissolve in water. So mostly the dirt will be always oily in nature, and we know that oil will not dissolve in water. The molecule of soap are sodium or potassium salts of long chain carboxylic acid. So what are soap? We have studied by saponification reaction. These are nothing but sodium or potassium salts of long chain carboxylic acid. This will be having two parts. One will be ionic end and one will be hydrocarbon end. So that is the next point. The ionic end of soap interacts with water while the carbon, nothing but hydrocarbon end, will interact with oil. So soap structure can be denoted like this. So we can denote soap structure like this. It will be a chain of potassium or sodium salts of carboxylic acid. So here I will write COO minus Na plus, or I can write potassium K plus. So if you see here, this is called as carbon chain or hydrocarbon part. Hydrocarbon part or hydrocarbon end. And here this is called as ionic part or ionic end. So this is the structure of soap. When you put this soap into the water containing dirt, so this ionic end will interact with the water and hydrocarbon end will interact with the oil, because hydrocarbon is nothing but oil which will interact with the same, like will interact together. Now we'll see the next point. So the next, that is point number 3. Soap molecule thus forms a structure called micelles, where one end of the molecule is towards the oil droplet and the other ionic end will be faces outside. So when we add this soap into the water, it forms one circular structure which is called as micelle. So this is the structure which is called as micelle. If you see in this structure, this is called as ionic part, and these all zigzag lines are called as hydrocarbon part. So these all the soap molecules in arranged in such a way that they will form a circle shaped structure where hydrocarbon part will be towards the center where there is a dirt, because dirt is also hydrocarbon and this is also hydrocarbon, and ionic part will be away from the dirt, outside, facing outside, because it's ionic and water also present at the outside. So like this the structure will form, and this is only called as micelle. So what happens? This forms an emulsion in the water. If you see the fourth point, this forms an emulsion in the water. The soap micelle thus helps in pulling out the dirt in water, and we can wash our clothes. Nothing but what happens if you imagine this is the cloth and this is the dirt which is present at the center, and all the soap molecule will form micelle like this. So this is your hydrocarbon part and this is the ionic part. So hydrocarbon part of soap will mix with the dirt and it will get dissolved. And when the ionic part is pulled by the water like this, it will be pulled by the water. This hydrocarbon part will take the dirt itself and comes out. And like this way, with the help of this, the dirt will be removed from this cloth. And like this, we can clean the clothes. So this is the cleansing action of the soap. So remember, when this question comes, you have to write this point and even you have to draw the diagram of this micelle. This is also very important. So this is the last question of part B chemistry. I hope you understood the answers of all each and every question. So students, if you like these videos, then for more such videos, like, comment and share these videos with your friends, and please consider subscribing my channel. Thank you so much.